Hi, welcome to my virtualization tutorial. This video I'm going to discuss about storage networking. It is a lecture series. We are in part 2. So today my agenda is to give some introduction about why a fiber channel is required in a storage area network, and we'll discuss about a simple SAN and what are the design considerations we need to take, and different type of fiber channel cables, and what are the different hardwares available for a fiber channel. There are different network topologies exist which helps to transmit the data to the storage. And zoning we'll discuss with the security point of view. Well, let's have some introduction about the scenario. So in a data center scenario, we used to have a server. Okay, the server is normally connected to the storage, and so to and fro the communication would happen to for what, read and write. Okay, basically a read request goes, or otherwise a write request goes. This is what normally happens, and this is normally achieved by SCSI, SCSI devices, SCSI adapter or host bus adapter, which is used. Now, why should I go for some other medium fiber channel devices? Okay, what's the requirement for this? It's purely depends on at what rate you want this transfer of data between this server and storage. So that decides what kind of medium which you are using for this communication. Either you are going with the fiber channel or going with the traditional SCSI. Now the fiber channel is faster than this one, and it offers 4 GB per second data transfer, and we can use the cable distances up to 10 km. 16 million devices can be interconnected, and it supports real-time hot swapping. So real-time hot swapping is something like when a system is running, you can plug and play devices. That is what hot swapping is. Normally storage, it support this storages. One of your disk made file, and you can just remove it and put the another one. So that we normally call it as hot swapping, and also it supports us to configure a fiber SAN. Fine. So this is how a simple SAN network looks like. You have multiple servers, server 1, server 2, server 3, and it is connected to a SAN switch, and the SAN switch can be connected to a disk array, and it is connected to a tape library with the help of SAN router also. Basically routes the data to the tape library. Okay, now what is the advantage here? We have a dedicated storage, fine, and can interconnect storage devices on their own high-speed network. So since it is a fiber channel, the network transfer will be faster, and allow the server to back up straight to the storage. Now, so it can straight away either write into the tape library also. That is also possible if proper routing is enabled, and this is better than LAN based. And suppose if you are designing a flyover cluster, definitely you need to think of designing a fiber channel network, so which will definitely improve the speed of your file. Considerations need to be in your mind when you design a storage area network with the help of a fiber channel. Okay, the question is, why would I use SCSI if fiber channel is so great? There are certain reasons. Okay, so the fiber channel is very expensive, including the components, everything, mediums and everything. It's very complex to implement when you compare with the normal standard Ethernet networking, and additional maintenance cost is also required. So obviously from this you can understand that, okay, when it is required. So definitely if you are an enterprise organization, definitely this is your requirement. Something like Microsoft or Google, they need this kind of networking. Rather you have a startup and having a small office. So is fiber channel is suitable for me? No, it's not required because data transfer rate will not be of much like in the enterprise grade. The considerations we need to have it in our mind before designing a storage area networking with the help of fiber channel. Time to discuss about fiber channel cables. So when we implement the fiber channel, what kind of cabling I should go for? It's again depends on the requirement. Again, when you look at, there are two options available. It can use copper kind of cable and fiber optic cable. Now what's the difference? Speed is the difference. 2 gigabyte, 4 gigabyte. So fiber optic supports 4 gigabyte. And what kind of configuration I can use? Intra cabinet and inter cabinet. These are the two options comes with. And what is the difference? Basically the length is the difference first. That is 13 meter it supports, and this second type inter cabinet supports 30 meters. And the number of enclosures, it allows only single enclosure, where inter cabinet supports multiple enclosures. And the modes, the kind of data transfer. Okay, there is a single mode as well as multi-mode transfer is there. Single mode covers max of 10 kilometers and 4 gigabytes per second, and expanded up to 10 gigabyte. And multi-mode supports again there are two types, 6.2 micron and 50 micron. It supports the first one 62.5 micron supports up to 175 meters, 50 micron support up to 500 meters. So these are differences. Okay, let's talk about HPA, host bus adapter, as you know already. So this basically connects or sit in between your server and the storage, which talks between your storage and server. So when a data transfer happens. Another important device in a storage area network is gigabit interface converter. This basically to convert your fiber channel data to a fiber channel switch. So just for conversion, that it enables you to connect your fiber channel in a switch. So there are straight connections also possible, switches nowadays allowing that as well. Now, the next device is switch. It helps to connect different devices of the network. So server can be connected to the switch, your storage can be connected to the switch, so that a connectivity can be established with your server to the storage. There are two ways to connect in the switch. One is with the help of GPIC, and second one is the fiber cable. Fiber cable straight away can be plugged onto your switch. And a different type of ports also supported in fiber channel networking. So the first type of port is called N port. N port normally exists on nodes, I mean the server. So which helps to connect a node to a fiber channel switch. So this is what, so this enables it to connect the server to get connected in the switch. And second type of port is called F port. That is normally this kind of F port exists on the switch. You can see one here, which enables a fiber channel fabric to be connected to an N port, okay, or otherwise to a node, we can say. Okay, L port enables you to connect to a fiber channel, and the NL port, okay, L for loop, we can say that loop port. NL port exists on nodes. It supports both loops as well as switch connectivity. Okay, so you can connect to a loop, or it can connect to a switch as well. And FL port is again exist on a switch. This basically helpful to connect a loop and switches. And E port or extended port, which exists on a switches, and so this basically helps to connect different switches. Okay, so you can cascade different switches and create a bigger network as well. So this E port to connect multiple switches to basically establishes a connectivity with the other switch. And G port, this also exists on a switch configured to emulate other port type. This can be configured to emulate any one of the other types. And last type is U port. This exists on a switch, I mean the fiber channel switch. The initial port state is on a switch. Before connecting any cables into that, changes its operation mode to E, P or F, FLP, G port and so on, based on the cable which you are connecting to that. Okay, that's all about fiber channels, and this ports helps us to do the different connectivity. The next device is hub. So hub is basically a shared one, something like a Ethernet hub. When your nodes are connected to the hub, only one node can transmit at a time. That is a drawback here. And bridge is basically used to connect different networks. So It establishes connectivity with the fiber channel to your SCSI device so that it can talk to the Ethernet network. So this is very obviously required when you have an existing network connective network. When you have a existing, this is obviously required when you have a existing network available based on Ethernet, so that your fiber network can talk to your normal Ethernet. Okay, it's time to discuss about topologies. Topology is the one which basically connects your server with the disk array and establishes the data transfer. So the first one is point-to-point topology. So this is a dedicated connection typically between your server and the storage device, something like a crossover cable, which we normally used to connect two different hosts. Okay, we use a crossover cable to connect host-to-host connectivity, the same thing. And switched fabric topology, so equivalent to Ethernet networking, and devices can be connected to a switch, and then from there it can be connected to the SAN port. So this is basically provide scalability. You can next one is the arbitrated loop technology. So this is equivalent to a token ring. So at a time only one device can communicate. So max of 127 nodes it supports. Okay, let's discuss about zoning. Before getting into zoning, let me give a scenario of what happens in a data center. You have different servers. Let's say server 1, server 2, server 3. These all can access the storages. You have multiple storage. This all connected to a network for data sharing, and servers also connected to this network. Now what happens? Literally the server 1 can access the data from this storage, and this storage. Absolutely this is not required, and this should be avoided. And whereas this access of a particular server, let's say server 3, should be confined with which storage device it is interacting. So other devices it should not communicate. So is single zone is good? According to our discussion, you would say no, this is not obviously required. So zoning is a technique which enables us to create a logical division. Okay, now look at the figure, and you can see that there are multiple zones. And when you look at here, server A cannot access storage B and C. Server B and C cannot access storage A, and server E cannot access storage A. Okay, it shows that clearly certain things are restricted. That means accessing of the storage B and A is restricted, C is restricted. It's the access is only given to the servers which is really need to have an access. So this provides a protection. Okay, and also it provides controlled accessibility. We are deciding this server can communicate with what storage. Okay, and there are some good practices also exist in zoning. You can zone by operating system. So Windows servers will running will be running from a single zone, and based on the HPA vendor also you can have a zone, and based on the application which you run, maybe web servers are running in a particular zone and your clusters are running in a particular zone, and zone by initiator port. This is the best practice actually. Zone by initiator port, something like this. You have an A, server A have an initiator. So your the server A has an initiator here, your storage has a target here. Okay, so this is the typical example for zone by initiator. So this kind of designs further improves the security, but this is little difficult to implement. So I believe you got an idea of how a zoning can help to isolate the resources and how to create a logical division over a data center. So these are my references. Thank you for watching the video.